Hello, my name is Anmol Soni, and today I will be discussing a very interesting topic in chemistry matter and chemical formula. Now, what is matter? So, look around wherever you're sitting. You can see a variety of objects which is living or not living. They have different shapes, sizes, colors, and exhibit different properties, uses, and states. Matter is anything we can see, feel, touch, which occupies space, and which can be perceived by our senses. Matter exists in many different states, like solids, liquids, gases, plasma, condensates like Bose-Einstein condensate, and crystals like plastic crystals, and much more. The image you see on your left is plastic crystal, and the image you see on your right is a few states of matter, like Bose-Einstein condensate, solids, liquids, gases, and plasma. Bose-Einstein condensate requires a very low temperature, like absolute zero or 0 Kelvin to exist, while plasma requires a really high temperature to exist. Composition of matter. Matter can consist of two basic substances, which is molecules and atoms. So basically, molecules and atoms are the things which make up a substance, whether it is solid, liquid, gas, or any states of matter. Let us start by discussing what are molecules. A molecule is the smallest unit of matter, which can exist independently. A molecule is a group of two or more atoms which are chemically bound together. Remember, they are chemically bound, not physically bound together. Two or more atoms of the same element combine together. For example, H2, which is hydrogen, and two or more atoms of different elements combine to form a molecule. For example, CO2 carbon dioxide, which is a mixture of carbon and oxygen. Atoms. Molecules are made up of tiny particles known as atoms. They're basically the building block of any given substance. Let us look at some properties of atoms. So an atom is the smallest unit of a substance, but atom has subatomic particles which are even smaller. It cannot be seen by unaided eyes, but we can see it by high-tech microscopes. In solids, they are tightly packed. In liquids, they are loosely packed. In gases, they are freely packed. Structure of an atom. The image you see on your right is basically the structure of an atom. And as I discussed, atom is made of even smaller particles known as subatomic particles. They are protons, neutrons, and electrons. So the blue color you see over here is a neutron. The red is proton and the green is electron. So proton and neutron combine together to form a nucleus, or the yellow circle you can see over here. And electrons orbit in a fixed path around the nucleus known as shells. Protons are positively charged, neutrons are neutral, and electrons are negatively charged. An atom is electrically neutral because it has equal number of protons and neutrons. So an atom can lose, gain, or share its electrons too. An ion is a charged particle formed by the loss or gain of electrons, where loss is denoted by minus and gain is by plus. Elements. An element is a pure substance made of only one type of atom. For example, oxygen, hydrogen, lithium, indium, neon, boron, nitrogen are all elements. There are 118 elements known so far. The atoms of one element is not as same as other. For example, gold is not the same as silver and boron is not the same as neon or argon. The element you see on your right is basically indium with a chemical symbol In and an atomic number 49. Compounds. A compound is when two or more elements combine in a definite ratio. So compounds have many properties. One of the properties are the properties of compounds are different from its original elements. We can easily check that because we can take an example of an experiment which is known as sulfur iron magnet test. Take a china dish and mix sulfur and iron together and try to bring a magnet near it. You will see that the small particles of iron is attracted to the magnet. Now do the same by heating the substance. It will form a black liquid substance and let it cool down. Once it is cooled down, it will be known as iron sulfide. And try to bring a magnet near it, there will be nothing getting attracted to the magnet. It cannot be separated by simple physical methods such as filtration and evaporation. And some examples are water, H2O, here hydrogen and oxygen are chemically bound together, and NaCl, where sodium and chloride are bound together. Did you know that sodium is a toxic element and chloride was used as a deadly weapon in World War II? But if you mix them both chemically, they form sodium chloride or common salt, which is totally edible. Mixtures. Mixtures are basically two or more substances physically mixed together. Remember when I mentioned in molecules when they're chemically mixed together? Here they're physically mixed together and they can be easily separated. Some examples of mixture is common air we breathe, as it contains all sorts of gases from hydrogen to argon to oxygen, despite argon is very less present in air and oxygen is very much present in air, around 21%. Water has some minerals mixed in it also, which can easily be separated by things like filtration and evaporation. Even soil is a mixture of different particles of different sizes. Chemical symbols. So picture this. You visit a chemistry lab and you see different kind of symbols like AU, HR, K, C, and etc. So those are nothing but the chemical symbols. They're either the Latin names or the first two letters of the elements. For example, Latin name aurum is for gold, which is chemical symbol is AU. The Latin name hydrargyrum is mercury, which is HR. Some examples of elements without Latin names are calcium, which is Ca, and neon, which is Ne. Did you notice something common in neon and calcium and its chemical symbols? Ca is the first two letters of the word calcium, while Ne is the first two letters of the word neon. This picture you see right over here is gold, and this is liquid mercury. Rules to form a chemical symbol. Chemical symbol usually consists of one or two alphabet. Some symbols are the first letter of the element's name. For example, hydrogen, which is H, oxygen, which is O, carbon, which is C, and nitrogen, which is N. When there are two or more elements beginning with the same letter, the first one is capitalized and the second one is in small font. For example, phosphorus and potassium. Phosphorus has P, the first letter, and potassium has got its Latin name K, which is kalium. And as discussed in my previous slide, the symbol of a few elements are delivered from their Latin name. For example, potassium, K, kalium. Now we go into a very interesting topic, which is picture symbols. So this page you see right over here was written by John Dalton in his book of Modern Atomic Theory between 1803 to 1808. Here he used picture symbols to represent elements from 1 to 39. Now I will read the elements from 1 to 39 and you can match them with the corresponding numbers. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, krypton, and rubidium. So that's all for this video. Thank you for watching. In my next video, I will continue with the topic atomicity. Please like, share, subscribe, and comment if you have any questions. Thank you.